Hello everyone and welcome back to our channel. So today we will learn how to monitor Java Maven app logs with Elasticstack. We will build a Java application using Maven and configure the structured logging with Logback. Then we will set up the Elasticstack, which includes Elasticsearch, Kibana and FileBit to collect, store and visualize these logs. And in the end, we will have a fully functional logging setup. So first, let's see the prerequisites. You should have AWS account with Ubuntu 24.04 EC2 instance up and running. Then at least 2 CPU cores and 4 GB RAM for smooth performance. And also Java and Maven installed in your system. So our first step is setting up Ubuntu EC2 instance. So first we will update the package list. Now next we will install the OpenJDK 17, which is required to build and run the Java application. Now OpenJDK is installed. Next, we will install Maven. Maven is a automation tool used for Java project. All right, so Maven is also installed. So our next step is creating a Java application with Maven. So first, we will create a directory named my Java app. Then let's navigate to it. Now we are inside the my Java app directory. Then next, we will use a Maven archetype to generate a basic Java project. You see the build success message, which means our project is generated. Let's navigate to the project directory, which is my app. Now our next step is configuring the Java application. So now we will start configuring the Java application to include logging and an HTTP server. So first we will open the form.xml file. Now inside this file, we will add the dependencies. So this is our form.xml file. So we will add slf4j logback dependencies. So let's copy, copy this property. This specifies the Java 17 as the source and target version. Sorry. The plugins. Okay. We are adding the Maven compiler plugin and Maven assembly plugin. This Maven compiler plugin compiles the Java code with Java 17 and Maven assembly plugin. Okay. This will create a jar with dependencies and also com.example.app as the main class for execution and runs during the package phase. You can see it's returning the execution instruction. Now let's save the file. Now next we will open the app.java file, which is located inside the src main java com example directory. Let me just remove this default code. This is our app.java. Let's copy this code and paste it inside our file. So here we are importing the HTTP server, then logger factory, and also Java IO exception output string and init socket address. Yeah, here this file uses the SLF4J with logware for structured logging. Here the logger info starting the application, and here it's creating an HTTP server which will be listening on port 80. It creates the HTTP server on port 8080 using HTTP server create and defines the request handler on the path slash here. Then we are also getting the client's IP address and port. Then this is the request handling and logging section. It retrieves the client IP address and port and also full URL of the request and request method, which can be get, post, and it also here below ignores the slash icon request by returning the 404 and logs the details of the incoming request. Okay, this is our response handling, which writes the hello world to the response. It sends the HTTP 200 response with the text hello world. Then it logs the sent response, which is hello world. Then finally, it starts the server. Then it will keep the application running. It returns the message application is running, ping for incoming request. So let's save this file. Now next we will create a directory inside our src main resources. We will create a resources directory. Now inside that directory, we will create a logback.xml file. This file is required to write a logback configuration. Now let's add this code inside the file. Here we have the console appender. This appender to log to the console. This log messages to the console and uses the pattern format which is written here. Then there is file appender appends to log to a file. It also uses the same pattern format as above. It logs messages to the file myapp.log, which is located inside the logs directory. Then there is root logger configuration. The info here logs messages to of level info or and higher, like warn and error, and it output logs to both console and file. Save this configuration. Now our next step is building the application. For that we will use Maven in package command. This will build the project and will create a jar file. So now you can see the build success matches such here, which means our project is built successfully and our jar file is also created. You can see the location here. Now next step is setting up Elasticstack for log monitoring. So now that our Java application is running, then next let's set up the Elasticstack to monitor these logs. So first we will import the Elasticsearch PG key. Then add it to the repository. Now repository is added. Let's update the package list again. Repository is added to the system's package sources. Now let's install the Elasticsearch. Our Elasticsearch is installed. So next, let's modify the Elasticsearch configuration for remote access. So let's modify the elasticsearch.yaml file. So scroll down here in the network, uncomment the network host. to 0.0.0.0. So what this will do? This will bind it to all available IP addresses. We will also uncomment the discovery seed source and we will keep it empty. You can specify the initial nodes for cluster formation. Okay, inside begin security auto configuration section, we will change the SPAC security enabled to false from true. Now let's save the file. Now our modification is saved. So let's enable the Elasticsearch. Then let's start it. Wait a minute until it starts. So now it started. So now let's check the status of Elasticsearch to make sure it's running. So now it's active and running. So let's send the GET request to check if Elasticsearch is running or responding. Now if it's successful, you should see the JSON response with cluster information. So here you can see it has returned us the information in JSON format. You can see the version 8.17.3, cluster name Elasticsearch, its IP address also. You can even access it using your public IP address. Let's copy it, paste it inside the URL, colon 9200 port, which is the default port for Elasticsearch. Here you can see. Now next, let's install the Kibana. Now Kibana is installed. Next, let's edit the Kibana configuration. So let's open the kibana.yaml file. Uncovering the server port and also server host. Change it from localhost to 0.0.0.0. So it will bind it to all IP addresses. Then we will connect it to Elasticsearch. So scroll down in the inside of the system Elasticsearch, uncomment the Elasticsearch.host path. So let's save the configuration. Then we enable the Kibana. Start it. Now let's check if it's running or not by checking its status. So it's active and running, as you can see here. Let's save the file. Sorry. Next, we will install the file bit. After installing it, we will modify the filebit.yaml. We will enable the file bit to ship logs from logs slash myapp.log file to Elasticsearch. So first, let's change the type from file string to logs. Here, comment out the unique ID. Here, then change the enabled from false to true. Now also we will change the path. The path will be home slash slash Java app, which is the directory we have created. Then my app is the directory created when we created the Maven application using archetype. Then logs my slash app, sorry, my dash app dot log. So it will take the input logs from this path, and for output, from outputs, keep the Elasticsearch output as it is, the output to Elasticsearch. And if you are going to use logstash, then just comment out the Elasticsearch output and uncomment the logstash output. Again. So let's save this configuration. Let's test the configuration file using sudo file test config command. And see the config OK message. Then next we will apply the file bit setup changes. Wait a minute. So it can take some time. So I will pause the video here. So now our file bit setup is completed. Next, we will enable the file bit. Let's start it. Let's verify if it's started or not by checking its status. So as you can see, it's active and running. Now next, we will ensure the Elasticsearch is receiving data from the file bit by checking the indices. So here you should see the file bit indices, the indices created by file bit. Now our next step is running the application. So let's execute the jar file to start the application, which is created when we run the Maven in package command. So now our application is started and is running, and it is looking for the images. Now let's open the browser, copy the public IP address, you can share the URL, then follow over to 880. So here you can see the hello world message means our application is running successfully. Now let's go back to the terminal. You can see the logs here generated, sent response hello world, and received get request from our URL. Here you can see the URL which we have used. These logs will be written to port console in the logs slash my app.log file. So you can even verify it. So for that, let's open the duplicate tab. Get inside the directory. Java slash now let's run this command. So you can see the logs are also written inside the file my app.log. Now our next step is visualizing these logs in Kibana. So again, let's go back to your browser and copy the public IP address, paste it inside the URL, then colon port 5601, which is the default port for Kibana. Hit enter. So this is the home page for Kibana. Let's scroll down and click on the logs option here inside the observability section. You can see the logs are generated. Let's just see the details. Here you can see the response saying hello world. The message is written here. You can even see the host name, the IP address. This is the private IP address of our EC2 instance. You can always verify it, which is 172.31.29.138. And here you can see this is our private IP address 172.31.29.138, and cloud region AP South 1, AP South 1 EC, which is availability zone, and instance ID. And you can also see the other details, the log path file which we have given. You can see it here, and shipper also inside the log details, and you can also view it in table format. You can see the agent type file bit and also its version, which is 8.17.3. Our instance type A3 large, then cloud service name C2. That's also much more. You can even view it in JSON format and see the path which is written here. we have a thing, the how to build a Java application using Maven and implemented the structured logging with logback. We have also set up the file bit to collect logs, which we have seen, and for these logs will be forwarded to Elasticsearch, and we have used stem inside the Kibana, and this setup provides a scalable and efficient way to monitor application logs, which helps the developers to gain insights and quickly resolves if any issues happen here, because error logs will be also generated here. And with this, you can also extend this system further by adding alerts. You can see here there are many options, and you can even add the dashboards, create dashboards here, and you can even import one or create your own. So that's all for today, guys. Thank you.